Swayam Prabha. Digital India. Educated India.
Hi, welcome back to Mechanics and Control of Robotic Manipulator. I hope the last lecture was interesting. Before going to continue the remaining example, I just want to give a again emphasize on the frame arrangement, and I'll be taking 4 such complex cases and sub cases, and I will show what is the difficulty in fixing frame some cases with respect to Danavid-Attenborough parameters. So that is what we are actually trying to see. So in that sense, what we are trying to go, we will try to go back what we have seen in the last lecture as the initial part, the frame arrangement. I am not going to you can say see in detail, but I will come back with 4 such cases where these cases are actually giving 2 axes, but in a different orientations how we can approach one to another. That is what the whole idea. So in that sense, you can actually recall all these things. So we know z axis always associated with joint, and the fixing the frame also if it is intersecting, the intersection point would be the ith frame, and if it is a parallel you can take convenient. Similarly, you can see the x axis always actually taken a common normal. If the common normal is not there, then the axis perpendicular to the plane containing the z axis, and you can actually please remember that the link length cannot be negative, right. So now we will come back certain example. Okay. So I got a case where the z1 axis given like this and z2 axis also given in this. So in this case, these two are parallel. So such cases we have seen in the last example. What we have done? So we have taken a convenient place and draw the, you can say, common normal, right. So then what we have done? We can actually fix your x1 axis, and this is the point 1, right. So in that case, what you can see, the alpha 0 would be, or in the sense 1 minus 1. So alpha 0 would be 0, and a 0 would be this length L, right. And you can actually say this is actually active or not, that based on that you can actually decide. So now theta 1 would be a variable, and the d1 in this case 0, right. So this is very easy. But now imagine there is a case which is actually given. Okay. So this is the case which is given. So where these two are actually non, you can say, parallel line. So it is actually slightly away, in the sense there is a motor here and the motor here, okay, like that. So in the sense it is actually connected this kind of member. So how we can do it? So it is actually again the same. You can actually push this, and what happened last case we said the d1 becomes 0. In this case the d1 would be this distance, right. So that is what we are actually trying to see here. So you can make a common normal, and now you can see that this is actually x1 direction, and this is what 1, and this is what 2, and now you can actually write it. So this is actually a0, and this is d1. So this is actually you can write as a d1, and we assume that this is actually rotation, or this is actually rotation. You can actually make it. So now if I write d1 or this, so it is actually slightly different. Why? Because we are always seeing this with respect to previous, right. So in the sense what we supposed to see, so if I am writing this frame, okay, so if I am writing the 2, so in the sense this is I, alpha I minus 1, a I minus 1, theta I, and di. So when we are writing actually here whatever number, this number with respect to previous we see, and this number with respect to progressing we see, right. This joint parameter is actually to see progressing, this link parameter will see with respect to previous. So in that sense, so this d1 and this a naught is not right. So that is what the whole idea, that is why I just plotted here. So in that sense what we can actually see it. So we will come back here. So what would be the case for 2? So the distance actually along x1 and the angle about x1, in this case it is 0. The distance along x1 is actually a1, and the angle with respect to Z2, if any, that is theta 2, and the distance along Z2 from 1 to 2 along Z2, that is what you call D2, right. So, now I hope you are clear on this. So, based on that we will see the next case, which is actually like little complex. What complex? I have taken the same plane, in the sense earlier also it is parallel, but now the parallel which is having offset in both x and y. Okay. So, in the sense you can see like this is in offset in two axes. How can we attempt? So, now it is actually like you can draw a common normal, then there is a multiple common normal. So, what would be the best common normal? You draw connecting this, right. So, now what you can actually like fix your x axis, you can fix your x axis this way, right. So, that is what we are actually like going to do. You can say we draw the common normal and you fix it x1 like this. Okay. Now, you can actually get it, and this is 1 and this is 2, but so in that case what you can see, this is L1 and this is L2. So, then this would be square root of L1 square plus L2 square, that you have to be remember, this would be A1, right. So, that you have to be very clear. So, in such cases what one can do? So, we can actually like do a passive plane, or you can say passive axis. So, I call this is 1 to 2, this is I call Z1 to 2. Okay. So, this I fix it x1 to 2, and this actually like I put x1. So, then what happened? So, instead of having a straightforward one joint information, I will be taking a passive joint of Z1 to 2, that I will take. Because of that what happened? This L1 and L2 would be addressed, not like the square root. So, this is one such simple example, you can think about it. Now, this actually like move up, what one can think? We can actually like again address what we did earlier. So, this is what we did. So, we address this actually like D2, right, and this is actually like L2 and this is L1. Either you can draw a common normal or you can go via passive frame, right. So, this is what the whole idea, right. So, now we can actually like see x1 we fix it if we want to go 1, right. So, now similar way we can see the case 3. What case 3? So, these two are not parallel but intersecting. So, then what is the easiest way? You can extend, and where the intersecting point, that would be the frame 1, right. So, that is what the rule of thumb, and the plane containing this Z1 and Z2, the normal to that would be your x1, right. So, the direction can be this or this. So, we are taking conveniently which is we are putting inside, right. So, that is what the whole idea. So, now in this case it is not big, but this distance what it cover? It cover as D2, and you have alpha, right. What would be alpha in this case? So, alpha 1 would be 90 degree, and A1 would be 0, and theta 2 would be based on the nature, right. So, now you are clear, right. This distance is actually like D2. So, that is what we are actually like writing it here, right. The same situation, but it is actually like slightly offset in both x, y, like we have seen in the sub cases, right. So, how we can do? So, in this case it is actually like non-trivial, right. It is not like a trivial case. So, what then one can think? So, you can make this. So, we can actually like do one simple aspect. So, you can actually like make one passive. So, what we can do? We can make it Z12 as a passive joint, and then actually like I can make it. So, this is x1 and this is ex1 to 2. This is easy for me, right. So, this is the way we can actually like make a, you can say, passive frame arrangement. Otherwise, this will not be directly addressed. But in this case you can see this is along x1. So, you can actually like call it as this is A1 and this is D2, right. But still if you want to make a passive frame, that is actually like more beneficial to understand, but this case even you can avoid, right. So, that is what we have actually like seen. So, now further cases in the same. So, we are actually like putting it so like this. Okay. So, what one can see here, the x would be coming either outward or inward, but this distance who would cover? Nobody will cover. Okay. So, but while looking it here, the x is actually like coming towards this, right, based on our, you can say, case. This is Z2 and this is the plane containing, and this is x1 direction. So this is actually like covered in, you can say, in x1. So that's why you should not actually like see directly from to here. So that's why you have to be very careful what is your joint axis direction and what way it is arranged, right. So now we will actually like go the fourth in the same sub cases. So what we can see here, there is a distance which is actually like, again you can see you can fix x1 here, and this would come under d2, this come under a1, right. So like that you can actually like cover it. So that is what we have seen. The fourth case is actually like very complex. So that is what going to give that real passive frame arrangements. What is that? You have seen, right. So this is actually like on this and this, but when you draw the plane containing this, so this is the plane containing, right. So what would be the direction of x? So which is actually like piercing in or coming out, right. So if that is the case, this distance is not covering in x, and this distance is actually like covering with z2, right. This is equivalent to d2, but this distance where it will cover. So now people can say, so you can draw common normal. No, the common normal would be the direction this, right. So then what one can do? So one can do is actually like easily, so you can actually like make a passive, in the sense you make it a passive frame here. So this is 1 to 2, and you fix your z1 here, 1 to 2, and then actually like you address this. So in that sense you can see still x1 here, so x1 to 2 here, but this would be covered as, so d1 to 2, right. So like that. So now you are actually like, I hope, understanding what is the benefit. So now this is straight away you cannot do it, so you have to come up with a passive frame. The passive frame can be done several mode. So one of the easiest mode, you extend the same distance and then you keep it, this is 1 to 2, that is the easiest option, and you keep your x1 as actually like whatever way you wanted to do it, either this or this, then you can actually like rotate, all those things you can do it, okay. So now the same way we can see even in the case for some other complexity. What complexity? 3 distances have come. So one in x, one in z, one in y. So how we will address? So in this case, so is there any way to do it? Yes. So what way we can do it? So this is actually like anyhow covering with z2, right. So what I can do, I can actually like come under something like this, okay, and this much distance I covered. So in the sense what I am trying to do, I am trying to keep this is as z1 to 2. So in that sense, so what would be the direction of x? It is actually like a parallel, so I can keep, and this distance, so this is 1 and this is 1 2, this distance will come as d1 2, this distance will come as d2, and this will come as a1 to 2, right. So like that you can actually like cover it. So this is what we can actually like see. So right now I am straight away writing because I have experience, right. So but you have to actually like come up with this. So that's why I am giving these cases, sub cases, so that the next time when I show some example, you will immediately realize why I have taken the frame in that way, okay. So now in that case, so this is the way we started, okay. So now we can actually like go the further more complex example. So this is parallel, right now we have taken the other way around. So then what you can see, so in this case, so one distance you can directly cover in x axis, right, because this is the plane containing z1 and z2. So obviously the plane perpendicular to that would be x1. So this distance you can cover as a1, but this distance you have to cover with a passive frame. What would be the choice? So I can take this is z1 to 2, okay. So in that sense what I can take, still I can take x1 to 2 this way. So this distance will come as d1 to 2, right. So like that you can actually like make a passive frame and then you can extend. Anyhow this passive frame will not be having any active joint, this distance automatically will adjust when you multiply, you can say 1 to 2 via 1 to 2, okay. So now the same way the last complex example is coming into a picture. So this is actually like not really a complex, because this is actually like we have done, and the same way we can do it here. What? So this distance would cover from here, and this distance would come as A1. So in this case A1 to 2, and this distance you have to cover. So this you can actually like take it as Z1 to 2. Okay. So then who would cover this, right? So in that sense, so we have to actually like see, not this way we can do it. So then what one can do, so you can use it as we did here. So this is 1 to 2, and keep it this as actually like Z1 to 2. So then this is cover as A1 to 2, and this is D1 to 2, and this distance as D2. Okay. So like that you can actually like make it. So this distance as D12, and this distance is D2, right. So these are the you can say complex cases. So I hope now you are actually like able to understand what exactly supposed to be known. So again I am actually like giving a small tip again and again. So if you talk about x axis, so if you are talking about xi, so you have to see the nature of zi and zi plus 1. Okay. If these two are actually like perpendicular or intersecting, or it is actually like plane containing, so then this would be perpendicular to that. If these two are parallel, then you have a easiest choice, you draw a common normal, conveniently you fix some point as a frame, then you can extend. Okay. So now when you write alpha I minus 1 or alpha I, so you have to see that the angle between zi minus 1 to zi about what, xi minus 1. So then the direction of rotation also matter, right. So for example, this is what xi minus 1 direction. So then the rotation is this way, right. If this is the case, so the rotation is like this. So that positive rotation you have to understand. Okay. For example, in this case, so what would be the alpha? So here you can see like this is the direction, so it is rotating. In this case it is 90 degree, right. But if you look at here, so this is the way. So what you can see, like it is actually like rotating, so 270 degree to make it, right. So this is what the further end, and when you talk about a minus 1, this would be distance along xi minus 1. Okay. From where? So I minus 1 frame to I frame along xi minus 1. So what is theta I? So theta is angle between, you can say, xi minus 1 to xi, okay, with respect to zi, that you have to be see. Again the positive rotation with respect to the z direction, right. So what would be the di? So di is actually like distance between, so 1 and 2 with respect to what, the zi. Again the positive or negative based on the direction of zi. Okay. I hope you are actually like clear on this. So with that I am actually like ending this particular short lecture. So we will see in the next lecture the detailed example which we left out in the last lecture, so that we would take up and continue it here. Okay. Until then, see you, bye, take care.